We're demonstrating a float-level sensor with our ultra-sensitive bipolar switch sensor, the ADT501. When we power up the circuit, the sensor detects the magnet positioned 4 inches below. You heard that right. The sensor actually detects the magnet over 100 millimeters away to activate the pump. When the magnet reaches level with the sensor signals to turn the pump off. It's very precise, stopping well within 1 millimeter despite the magnet floating inside the bottle around 2 inches away. Since we didn't add hysteresis, you can see the sensor periodically turns the pump on and off until the magnet is perfectly level. How is the sensor able to achieve such precision? This sensor is an ultra-sensitive polarity switch, usually used for rotation sensing, but it can detect single-axis magnetic fields too, and that's exactly how we use it in this demo. Here is a typical sensor performance showing remarkable resolution as a polarity detector. In our float sensor demonstration, the sensor is oriented to detect the y-axis field component. The graph is the simulated magnetic field of the magnet we used in the float. The ADT501 can detect this magnet from 4 inches away. As the magnet travels towards the sensor, the y-axis field reaches a maximum and keeps the same polarity. Only when the magnet crosses the sensor does the polarity reverse. After the polarity reversal, the field increases rapidly, which trips the sensor. Using the y-axis field component and a bipolar sensor is a robust method to prevent double switching, which can be a common problem when trying to sense the x-axis field component. Moreover, it allows for easy calibration because the polarity reversal is always in line with the center of the magnet. We're using our new DB002 evaluation board to interface our sensor to a large contactor. The ADT501 itself is a micropower sensor designed to drive GPIO pins, but the DB002 turns it into a rugged industrial sensor with transient protection and high load driving capability. The sensor is below the float now, and we can actuate the relay by passing the magnet. We set a level and the sensor will detect when the magnet crosses its plane. We'll give the pump some voltage. The sensor can detect the magnet even in this larger jar, which introduces an air gap of up to 4 inches. That's a ridiculous amount of design margin for a sensor to operate in. Here are the boards we use for this demo. Key features for ADT501-10E rotation sensors include wide magnetic operating latitude, ultra-low power suitable for battery operation, small package size, and wide temperature range. Click email or call for more information or to buy parts and evaluation boards today. Like the video if you enjoyed it, and subscribe to the NVE Corporation YouTube channel for more product demonstrations.